Hi class, welcome to week 3. Again, we are moving right along very smoothly and very quickly. We are in week 3, lecture 3. How was you guys' weekend or how was the week last week? I hope you enjoyed it because we have more fun and learning things that we need to go over. So I hope you guys are really enjoying the class. This week we are or will be discussing sensations and perception, including stress. The objectives for this week is to explain the various ways people use defense mechanisms, determine the strengths and weaknesses of the trait theory of personality, evaluate the impact of brain and genetics of personality, and this week, the role of sensations that includes vision, hearing, touch, taste, smell, or the sense of motion and position used by the brain considered. The brain is everything when it has something to do with psychology class. Perception is awareness of what is happening based on what one senses. The level of consciousness is an awareness of environment that may be altered by sleep or substances. However, vision and studying the many processes of sensation and perception, the most widely studied and understood is vision. The physical stimulus for vision is light, which stimulates the eye. Light from characteristics, wavelength, intensity, and pureness. These characteristics are seen by us as hue, brightness, and saturation. Changing any of the physical characteristics of light waves makes a difference in our experience of the light, and it alters the operation of the eye. The source of the most of our light, the sun, emits white light, which is a mixture of all light wavelengths. This can be demonstrated by passing sunlight through a prism, as seen in the prism. A prism spread light out into the colors of the visible spectrum. Hue identifies the perceived color of a particular wave. As wavelength changes, hue also changes. As the intensity, amount, or magnify of a light wave increases, the result is an increase in perceived brightness. Brightness is related to the amount of light present. The light meter, photometer, in a camera measures the intensity of physical light waves entering the lens. A totally saturated color is a pure light wave, but we don't see this very often. About as close to pure color as you see in the everyday world is the colors of a rainbow produced on a day of clear air. A pure red will have light waves of only one particular wavelength. And unsaturated light must be black, gray, or white. As you add white light to a pure color, the color becomes less saturated. If you mix all colors together, you create white light again. Saturation is also sometimes called purity. This refers to the extent to which a particular hue is mixed with the white or other light. Hue, brightness, and saturation must all be mentioned to describe fully any light source. All three dimensions presented in a color can be seen Difficulties in perceiving color can lead to various problems with vision, ranging from relative mind color insensitivities to color blindness, and at the worst, blindness. The color solid, no, excuse me, class. We use the color solid for predicting addictive mixing of spectral colors. The hue depends on the light waves which are added together. The pigment of paint absorbs almost all but one color of the spectrum, as does colored glass. Used in psychology, color. An interesting application of the principles of sensation and perception involves their application on how we dress ourselves or decorate our environment. Colors as well as shapes and lines can play a vital role in projecting an image and creating a mood. Think of the many common expressions that recognize this fact. Seeing red, green with envy, feeling blue in a blue funk, purple passion. Some colors are cool, such as blue. Yellow, orange, and red are warm colors. Green is the only color that looks cool in the summer, warm in the winter. Do you tend to wear brighter colors on a gloomy day? Of course. Some colors are simply more becoming to you than others. Your own coloring will make a difference. Wearing blue can improvise blue eyes. Wearing yellow can make a yellowish skin look sick. You can contrast clothing colors with your own colorations or choose them to harmonize. If you are looking to wear two colors, it's the best way to wear two complementary colors, meaning colors directly across from each other on a colored circle. If you're using three colors, use colors that are about 1200 apart from one another on the color circle, so as not to appear too loud. As a dresser, use less saturated colors. Blending with the scenery can pose a safety hazard to humans. Pea green slickers are best for visibility on rainy days. Snow skiers are safer not wearing white. You can extend the safety principle to your car as well. What colors will make it more visible in a fog at night or in a rainy day? The most visible is, guess what color, you guys? The most visible color is white. Of course, the lesson of dressings can also apply with the choice of colors and fixing up your room or decorating in general. Again, apply the principles of perception to gain control over how your environment and you will proceed. The eye. The receptor for visible light is the eye. The reception for visible light is the eye. The eye is in many ways similar to a camera, but it is much more complex. Light enters the eye through the pupil and is focused by the lens. The light falls on the retina, which is similar to the film in a camera. The retina is made up of two receptor elements called rods and cones. Rods are more light sensitive than cones, so they are used to see in poor light, especially at night. Cones are sensitive to color, but they demand more light to function. Rod vision is comparable to black and white television. Cone vision is similar to color television. The rods and cones connect with neurons that form the optic nerve, which relay visual information on the brain. The point at which these neurons exit from the eye is called the blind spot. This is a very small portion of the retina that has no receptor cells. Stimulation on the blind spot will not be received by the brain. Think about it. Instructors in driving educational classes often advise their students to look twice in both directions before driving across intersection. Why is that? If you look into the right and to the left only once, it is possible that the image of a car coming from the right might fall on the blind spot of one eye. It might then be obscured from vision in the other eye by the right front roof support of your car. If the approaching car is moving fast enough to hit you, then looking again at the same spot will prevent an accident. This should allow enough time so that the image of that car will not fall on your blind spot both times. And that is so true, class, because I look in my blind spot at least twice before I switch lanes. That is very important to me. I am a very cautious driver, and I know that a lot of young people likes to drive fast, speed, and likes to race other cars. But I'm a very cautious driver, so I do look in my blind spot twice before switching lanes. So that question was for me. And that is all for this week. And I hope you enjoyed my lecture. And I will see you in week 4. Take care, you guys.